Good afternoon to judges and audience. We are presenting you the Compressed Air Gravity Storage System, CGSS. The world is currently looking to explore the renewable sources that are clean and not emitting carbon dioxide that contributes toward the greenhouse effect. One of the best candidates is the solar energy. According to the Renewable 2020 Global Status Report, the demand on the solar voltaic cell increased drastically until the year of 2019. This shows how the world really demanding on the renewable energy and as well as tackling the climate change as the goal listed in the Sustainable Development Goals (SDG) by United Nations. Although the limitation of the solar panel is still a challenge, it is a variable, intermittent, and general dispersed source when compared to a large-scale power plant such as hydroelectric plant. By December of 2017, only 27.7% of the power produced are from the renewable sources, but they only ended up supplying 22.8% of the worldwide electricity. This raises the importance of the energy storage when supply is available but the demand is weak. Therefore, the use of energy storage system increase the energy reliability, security, and support a greater integration of renewable energy and avoid the interruption of the intermittency. The ideal system should operate around the midday, which is a peak of generation, then transferring the excess energy to the peak of demand. Thus, the energy generated by the photovoltaic installation during the hour of low demand can be stored and used at night. So Kai, could you insight me on the energy storage system?
This is absolutely a good question, Yoong. In the context of energy storage system, pumped hydro energy storage, PHES, and compressed air energy storage, CAES, are matured and large-scale commercialized technologies. PHES uses the excess electricity during the off-peak periods to store the energy by moving the water from the lower reservoir to the upper reservoir. During the peak hours, the energy is generated by releasing the water from the upper reservoir to the lower one. However, this system suffers from the limitation of the geographical sites because it requires a high difference between these two reservoirs. For CAES, uses the off-peak electrical energy to compress the air and store in the underground cavern or above-ground vessels. During the peak periods, the stored air is used to produce the electricity through the turbine generator after being heated and expanded. The major disadvantages of CAES is low efficiency. In order to break through the limitation of the PHES and CAES, the combination of their working principle will be the ideal solution. This novel system is called Compressed Air Gravity Storage System, CGSS. CGSS is powered by photovoltaic plant. Photovoltaic plant absorb the photon from the solar energy to generate the electrical energy. During the storage discharging mode, excess electrical energy is used to pump the water into the container. As a result, the piston will compress the air until reaching the maximum pressure that can be withstood by the system. During the discharging mode, the high pressurized air will push the piston downwards, forcing the water to pass through the turbine and drive the generator to produce electrical energy. In short, CGSS can perfectly overcome the limitation of the geographical sites faced by the PHES as well as the limitation of the low efficiency faced by the CAES. Now let's take a deeper insight into the CGSS working theory. I shall pass it to Johannes.
Alright, thank you Kai for explaining the working principle of CGSS. Now, let's move on to the theory part of CGSS. So, during the charging stage, pump is used to force water and push the piston to move up and compress the air. So, volume of air decreases and pressure increases, hence, energy could be stored. But on the other hand, while discharging, the high pressured air will push the piston down, which then apply a high pressure on water, and this time, volume of air increases and its pressure decreases. It will push the piston down and force the water to turn the turbine. The force of water exerted on the blades rotate the rotor shaft of the turbine generator. Thus, mechanical energy will be converted to electrical energy. Next, there are a few factors which will significantly affect the total energy produced by CGSS. They are namely the container's height, maximum allowable pressure, container's volume, and air-water ratio. So now, let's take a basis of 20 MWh. For a normal gravity system to produce this amount of energy, 500 meters of height will be needed. But for CGSS, only 375 meters will be required to produce this amount of energy. Next, we use the basis of 1 megawatt hour of solar energy. In that 1 megawatt, 0.22 megawatt will be converted to usable energy from the solar panel. And then from that 0.22 megawatt hour, 0.17 megawatt will be stored as compressed air, thus giving an efficiency of 77% for CAGSS. So now, let's take a look on the cost and profit of this system. I shall pass the time to Suba.
Thank you, Johannes. Now, I'll move on to the economic and environment analysis of the system. Compressed air gravity storage has a good potential in terms of economic. As extension from Johannes, 1 megawatt per hour of solar energy able to provide 7 household capacity per day. Based on our rough calculation to the average TNB tariff, we can earn about 37 ringgit 88 cents per day. The cost of the investment in the beginning due to the purchase of equipment can cost about 12,000. From the return of the investment, the payback period is around 9 years. After this period, we will be able to gain profit from this system. Other than the numbers being mentioned above, its ability to compress air in order to decrease the height of the container also economic in terms of the reduction in the excavation cost. Excavation cost that increases with that will cause a major increase in system construction costs. Next, CAGSS also do not require heating and cooling process, so can reduce the cost in terms of equipment needed for heating and cooling process. As for the environmental analysis, as we are aware that reducing usage of fossil fuels in generating energy surely put a stop to various kinds of environmental effects, such as global warming due to the reduction of greenhouse gases emission. Other than that, as CAGSS requires minimal land use, this will also reduce the act of clearing forests for generation of energy. Potential location that we could place this system is abandoned mines and water reservoir. Thus, we would like to suggest Mehmet Mine, abandoned mine at District Ranau, Sabah. This is just what we are looking for, abandoned mine, and it also has a depth of 500 meters, which is more than enough than needed for this system, which is 12 meters. Thus, the cost of installation and implementation costs can be low because existing abandoned mines can be used.
Thank you, Suba. So, in conclusion, CAGSS is the most optimal solution to the energy crisis. CAGSS meets the standards of the sustainability and the profitability, as we can see the integration with the renewable sources, which is solar energy, and its tangible profit. In the context of mechanism, CAGSS can overcome perfectly the geographic restriction and the efficiency of existing energy storage system. With the potential base we suggested earlier, we can even upscale our simulation to fully utilize the capacity of the 500-meter deep mine to maximize our profit in the fastest pace. And that's all from us. Thank you.